At 0100 hours on November 15, 1942, USS Washington's radar operators watched a large contact appear on their SG Surface Search radar scope. Range 8,400 yards, bearing 330 degrees. The target was a battleship, moving slowly through Iron Bottom Sound, unaware that American guns were tracking her through pitch darkness. 4 American destroyers were already sinking or burning. USS South Dakota, the other battleship in Task Force 64, had been battered by Japanese gunfire after electrical failures knocked out her systems. Japanese searchlights swept the water, searching for more targets, but they couldn't find USS Washington. The Japanese battleship Kirishima had no radar. Her lookout strained to see through the darkness. Her optical rangefinders were useless without light. Her fire control officers had no idea an American battleship was less than 5 miles away, with guns already trained on their ship. On Washington's bridge, Rear Admiral Willis Augustus Lee stood next to Captain Glenn Benson Davis. Lee had been tracking the Japanese force on radar for 20 minutes. He knew exactly where every enemy ship was. The Japanese knew nothing. What happened in the next 7 minutes would change naval warfare forever. Night naval combat in 1942 was dominated by the Imperial Japanese Navy. For 2 decades, the Japanese had perfected tactics that made darkness their ally. Intensive training in low-light conditions, superior optical equipment, and aggressive doctrine built around rapid torpedo attacks and close-range gunnery. Japanese destroyer men practiced night maneuvers until they could fight blind. This doctrine had produced devastating victories. In August 1942, at the Battle of Savo Island, Japanese cruisers surprised an Allied force and sank 4 heavy cruisers in 32 minutes. American ships had early radar systems, but commanders didn't trust the technology. By the time lookouts made visual identification, Japanese long-lance torpedoes were already in the water. On November 13th, the first phase of the Naval Battle of Guadalcanal became a point-blank brawl. American cruisers and destroyers engaged Japanese battleships at ranges under 3,000 yards. Ships fired at muzzle flashes. Searchlights blinded gun crews. The Americans stopped the Japanese bombardment of Henderson Field, but at catastrophic cost. 4 destroyers sunk, 2 light cruisers sunk, multiple ships damaged, over 700 American sailors dead. Rear Admiral Daniel Callahan and Rear Admiral Norman Scott both died in the action. They were the only 2 American admirals killed in surface combat during the entire Pacific War. The cruiser force was shattered. Henderson Field had been saved for 1 more night, but the Japanese were coming back. Vice Admiral Nobutak Kondo was bringing battleship Kirishima south with cruisers and destroyers to shell Henderson Field on the night of November 14th. If the airfield was destroyed, Japanese reinforcements could land unopposed and retake Guadalcanal. Admiral William Halsey had almost nothing left to stop Kondo's bombardment force. His only option was to strip USS Enterprise of her battleship escorts and send them into Iron Bottom Sound for another night engagement. The problem was that night engagements favored the Japanese. American ships had better radar than they'd had at Savo Island, but radar alone hadn't prevented disasters. The technology had to be integrated into tactics and command decisions. Most American flag officers in November 1942 still thought of radar as an interesting experimental tool, not a weapon that could dominate combat. Most admirals were cautious about relying on it completely. Admiral Willis Lee was different. When other admirals said radar was unproven, Lee said radar would decide who controlled the Pacific. Willis Augustus Lee was 54 years old in November 1942. Born in Kentucky in 1888, he graduated from the Naval Academy in 1908. At the 1920 Antwerp Olympics, he won 7 medals in shooting competitions. 5 gold, 2 silver, 1 bronze. He was the most successful athlete at those games. His specialty was long-range rifle shooting, where tiny variations in wind, temperature, and distance determined hits or misses. Lee understood that hitting targets required precise measurement and careful calculation. Those same principles applied to naval gunnery. Between 1941 and 1942, Lee commanded the Director of Fleet Training for the Atlantic Fleet. In that role, he worked directly with engineers developing radar systems for fire control. He visited Naval Research Laboratory facilities where radar prototypes were tested. He studied British reports on radar-directed gunnery. He examined after-action reports from every engagement where radar had been used. Lee became the Navy's foremost expert on integrating radar into combat operations. When Lee took command of Washington in September 1942, he immediately began intensive radar training. The ship's SG surface search radar could detect ships at ranges up to 40,000 yards in optimal conditions. At night, it was far more accurate than any human lookout. The fire control radar could track targets continuously and feed data directly to the ballistic computer. But the equipment was only as good as the operators using it. Lee drilled his radar teams constantly. They ran simulations in daylight and darkness. They tracked friendly ships during exercises. They practiced until radar operation became instinctive. USS Washington was a North Carolina-class battleship, one of the most modern warships in the world. Laid down in 1938, launched in 1940, commissioned in May 1941. Displacement 35,000 tons standard, 44,800 tons fully loaded. Length 728 feet, beam 108 feet, maximum speed 28 knots sustained. Armament consisted of 9 16-inch Mark VI guns in 3 triple turrets, 25-inch Mark 12 dual-purpose guns in 10 twin mounts, numerous 40mm Bofors and 20mm Oerlikon anti-aircraft guns. The 16-inch guns could fire 2,700-pound armor-piercing shells to a maximum range of 36,000 yards. Rate of fire was approximately 2 rounds per minute per gun. The armor belt was 12 inches thick at the waterline, sloped to increase effective thickness against plunging shells. Deck armor was 6 inches over magazines and machinery spaces. The ship's radar suite was extensive for 1942. The SG surface search radar operated on 10-centimeter wavelength. It used a rotating antenna mounted high on the superstructure to scan 360 degrees continuously. The display showed contacts as bright spots on a cathode ray tube. Operators could measure range and bearing with reasonable accuracy. The fire control radar, designated Mark III and Mark IV systems, tracked specific targets for the main and secondary batteries. These radars fed data to mechanical fire control computers that calculated gun solutions accounting for ship speed, target speed, range, wind, temperature, and barrel wear. On November 14th, Washington departed with South Dakota and 4 destroyers as Task Force 64. The force reached Iron Bottom Sound that evening and began patrolling near Savo Island. Lee positioned his destroyers in the van to detect enemy ships early. The 2 battleships followed in column. Washington's radar began detecting contacts at 22:30 hours, multiple ships approaching from the northwest. Lee recognized the formation as the expected Japanese bombardment force. He maneuvered to intercept, but the situation rapidly deteriorated. At 23:17 hours, the destroyers encountered Japanese screening forces. USS Walk was hit by a long-lance torpedo that blew off her bow and detonated her forward magazine. She sank in minutes. USS Preston was caught in concentrated gunfire from Japanese cruisers and destroyers. Multiple hits set her ablaze. She went down at 23:22 hours. USS O'Bannon took a torpedo hit that shattered her bow. She survived but was dead in the water. USS Gwynn was damaged by shellfire. Within 10 minutes, Lee's destroyer screen was effectively destroyed. South Dakota followed Washington through the engagement area. At 23:25, the battleship suffered a catastrophic electrical failure. A circuit breaker that should have been open was closed, causing multiple systems to cascade into failure. Radar went down. Radio communications failed. The fire control computers lost power. Gunfire temporarily knocked out additional circuits. South Dakota was blind and nearly helpless. She steered too close to the burning destroyers and was silhouetted against their flames. Japanese searchlights locked onto her. Kirishima, cruisers Otago and Takao, and multiple destroyers opened fire. South Dakota was hit 27 times. Most shells struck her superstructure, causing extensive damage to unarmored areas. One 14-inch shell from Kirishima penetrated near her waterline but failed to detonate. The battleship survived but was forced to withdraw. Washington's situation was different. Captain Davis had maneuvered to port, keeping the burning destroyers between Washington and the Japanese force. The Japanese couldn't see Washington. Their searchlights never found her. Washington's radar operators tracked multiple contacts. Lee studied the displays. The largest contact was clearly a battleship, range closing to 8,400 yards. Lee waited. He wanted positive identification before opening fire. If that contact was South Dakota, Washington would destroy a friendly ship. But Lee's radar operators confirmed South Dakota was behind Washington, not ahead. The contact was hostile. At 0000 hours on November 15th, Lee gave the order. Commence firing. Washington's forward turret, Turret 1, trained onto the bearing provided by fire control radar. At 0001, the first salvo fired. 3 16-inch guns discharged simultaneously. The muzzle flash illuminated the entire ship for an instant. The shells departed at 2,500 feet per second. Time of flight to target, approximately 20 seconds. The first salvo hit Kirishima near her forward turrets. 30 seconds later, the second salvo fired. 9 guns now, all 3 turrets in battery. More hits. Kirishima's searchlights went dark. Washington's 5-inch secondary battery engaged simultaneously, firing at Japanese cruisers and destroyers. The smaller guns could fire much faster, 3 to 4 rounds per minute per gun. For 7 minutes, Washington poured fire into the Japanese formation. Her main battery fired 75 rounds of 16-inch ammunition. Her secondary battery fired 107 rounds of 5-inch ammunition. The fire control radar tracked Kirishima continuously. Every time the battleship maneuvered, Washington's guns adjusted. Range varied from 8,400 yards to 12,650 yards as both ships moved. Post-battle analysis determined that Washington scored at least 9 direct hits with 16-inch shells and approximately 40 hits with 5-inch shells. The 16-inch armor-piercing shells each weighed 2,700 pounds. When they struck Kirishima's hull, they punched through her armor and detonated inside. The first hits destroyed her forward turrets. Subsequent hits penetrated below the waterline, flooding multiple compartments. One shell jammed her rudder, forcing the battleship into an uncontrolled turn to port. Hits on her superstructure destroyed fire control stations and communications equipment. The bridge was hit, killing multiple officers. Fires spread through the damaged areas. Kirishima was a Congo-class battlecruiser, built in 1915 and modernized in the 1930s. Originally designed for 27-knot speed with relatively light armor, she'd been upgraded with additional protection during reconstruction. But she was still fundamentally a 30-year-old design. Her armor belt was thinner than Washington's. Her compartmentalization was less sophisticated. Her damage control systems were inferior. When Washington's shells began hitting, Kirishima couldn't withstand the punishment. By 0007 hours, Kirishima was listing heavily to starboard. Flooding was uncontrollable. Her engineering spaces were taking water. Power was failing. Her guns had fallen silent. Admiral Kondo realized the bombardment mission was impossible. He ordered the force to withdraw. Japanese destroyers attempted to take Kirishima under tow, but the flooding was too severe. At 03:20 hours, November 15th, the crew abandoned ship. Scuttling charges were set. Kirishima capsized and sank northwest of Savo Island. Over 200 crew members died. The remainder were rescued by Japanese destroyers. Washington suffered no damage during the entire engagement. No shell hits, no casualties. Lee's maneuvering and the Japanese focus on South Dakota meant Washington fought the entire battle undetected. The victory was complete. Japanese forces withdrew without bombarding Henderson Field. The transport convoy following the bombardment force turned back. The strategic threat to Guadalcanal was broken. The engagement demonstrated everything Lee believed about radar. Washington detected Japanese ships at ranges where visual observation was impossible. She tracked multiple targets simultaneously. She maintained accurate firing solutions despite darkness, smoke, and maneuvering. She destroyed an enemy battleship in 7 minutes without being detected. The technology worked perfectly because Lee had trained his crew to use it properly. The implications were profound. Before November 15, 1942, night combat favored the Japanese. Superior training and optical equipment gave them decisive advantages. After that night, radar-equipped American ships dominated night engagements. The Japanese had no answer. They never developed effective radar fire control systems. Their ships continued relying on visual observation and optical rangefinders. In every subsequent night battle, American radar provided overwhelming tactical advantage. Admiral Willis Lee never saw the end of the war. On August 25, 1945, 10 days after Japan surrendered, Lee suffered a massive heart attack in a motor launch crossing Casco Bay to his flagship USS Wyoming. He collapsed and died before reaching the ship. He was 57 years old. 3 years of constant combat operations had taken their toll. Lee was buried with full military honors at Arlington National Cemetery. His grave is marked with a simple white marble headstone listing his name, rank of vice admiral, and dates. It mentions his 7 Olympic medals. It doesn't mention Guadalcanal. It doesn't mention that he proved radar could revolutionize warfare. Lee probably would have preferred it that way. He was never interested in glory. He was interested in solving problems and winning battles. Washington's victory saved Henderson Field. Japanese forces never again seriously attempted to destroy the airfield with naval gunfire. The campaign might have been lost without that victory, but the greater impact was proving that radar could dominate surface combat. Before November 15th, radar was experimental technology. After that night, radar became recognized as the foundation of modern naval warfare. The transformation happened quickly. In January 1942, fewer than 100 American warships had radar. By January 1945, virtually every American warship had multiple radar systems: fire control radar, air search radar, surface search radar, identification systems. The electronic equipment became as important as the guns. The lesson from Washington's victory isn't ultimately about technology. It's about leadership willing to trust new technology when conventional wisdom says otherwise. Admiral Lee had decades of experience with traditional naval gunnery. Every instinct should have told him to be cautious with experimental electronics. Instead, Lee committed entirely to radar because he'd studied it, tested it, and trained his crews to use it. When the moment came in pitch darkness, Lee trusted his radar operators completely. They didn't let him down. The victory validated everything Lee believed. It proved electronics could be more reliable than human senses. It demonstrated that properly integrated technology could overcome numerical inferiority. Most importantly, it showed that innovation succeeds when leaders understand new capabilities deeply enough to trust them completely. Admiral Lee organized his ship around unproven technology. He trained his crew to fight in ways no navy had fought before. He committed his entire force to a battle plan that depended on radar working perfectly. The result changed naval warfare forever. Night combat became an American advantage almost overnight. The radar that seemed revolutionary in 1942 evolved into the modern combat systems that control warships today. USS Washington's victory deserves to be remembered for what it represented: a leader willing to trust new technology, a crew trained to use that technology effectively, a tactical victory that changed strategic reality, and a demonstration that innovation succeeds when knowledge replaces assumption, when study replaces tradition, and when courage to act differently produces results impossible under old methods. If this story resonated with you, please like this video. Subscribe to ensure you don't miss future episodes about forgotten moments from World War II. Drop a comment below telling us where you're watching from. From Pearl Harbor veterans to Pacific history enthusiasts, you're part of preserving these stories. Each one matters. Each one deserves to be remembered. Thank you for watching, and thank you for keeping history alive.